Open any tech blog or listen to a recent earnings call, and you will hear endless debates about the AI economy. They argue over parameter sizes and which foundation model is the smartest. But if you look at the balance sheets, hundreds of billions of dollars are suddenly evaporating from tech market caps. The hyperscalers are racing to build artificial general intelligence, pouring fortunes into massive data centers. Yet they are entirely ignoring the exact unit of physics that will dictate whether this technology survives: the millisecond. Our macroeconomic models are currently detached from the physical reality of time. Because we treat time as an abstract concept, the industry is blind to a massive systemic threat. The hyperscalers believe they are in a race for total market control. In reality, they are accelerating toward a systemic collapse, a violent collision known as the clash of clocks. To understand why tech giants walk into this trap, look at how they build. Silicon Valley traditionally solves complex problems by isolating them. They build massive, proprietary walled gardens, closed environments where they control every variable. Inside these isolated silos, the millisecond makes perfect sense. To developers, it is just a metric of latency. It is simply the tiny fraction of a second it takes for their model to retrieve an answer or execute a line of code. But the established playbook, hoarding scraped data and training massive foundation models in secret, has quietly hit a ceiling. We have reached an organizational limit. The bottleneck in the AI economy is no longer the intelligence of the model. The hard limit is the silo it is trapped in. A foundation model can be a genius in a vacuum, but eventually an autonomous AI has to step outside its digital silo to interact with the real world. It has to route actual capital, book physical logistics, or draw real power from the local grid. When it does, it attempts to execute those complex decisions at its native speed, milliseconds. This is where it hits a temporal brick wall. That lightning-fast digital command collides with a physical power grid, which operates on slow, legacy load balancing. It attempts to coordinate global supply chains, only to find physical infrastructure weighed down by 90-day settlement lags and the slow crawl of cargo ships. You have a frictionless intelligence trying to operate in milliseconds, dropped into an asynchronous physical reality that takes months to clear a transaction. The two systems violently shear against each other. To survive this massive friction, hyperscalers are being forced to trap trillions of dollars in counterparty reserves. They are hoarding capital simply to pad the time gap between a digital execution and its physical settlement. If the AI pushes its execution speed too hard without that padding, the system fails physically. It triggers a thermodynamic flash crash. The localized grid infrastructure literally breaks. It cannot handle the instantaneous demand, snapping the physical capacity of the system. The physics dictate the outcome. You cannot run a millisecond speed digital intelligence on an asynchronous, low-frequency physical planet without causing a catastrophic failure. As humans, we instinctively resist this high-speed shift. We worry that letting machines operate at this pace means surrendering our own agency, that we are building our replacements. We feel that way because of how these tools were born. They weren't built as an extension of our local communities. They were created in speculative silos, completely disconnected from our shared physical environment. Consider that human nerve impulses travel at speeds up to 120 meters per second, with the brain processing sensory input in millisecond windows. Machine intelligence has finally reached the same biological threshold of the living world. To maintain human agency at these speeds, the machine cannot remain a siloed tool. It must be integrated into the local infrastructure as a functional extension of the environment, a framework known as Intelligence Augmentation. To scale safely, we must change the macro environment and build a global millisecond network. It synchronizes Layer 1, physical reality, with Layer 2, digital markets. This requires real-time gross settlement, T0. Execution, capital, and energy must all collapse into the exact same millisecond. This creates an automatic physical failsafe. If an autonomous agent attempts an action that exceeds the actual energy capacity of the local grid, the T+0 circuit physically refuses to close. The action is blocked. The macro environment now dictates the speed of the intelligence. Success follows the architecture that successfully synchronizes the digital pulse with the thermodynamic and social reality of the human commons.